All right, I'm recording it. Go ahead.
Hello, everyone. Welcome to the Sea Ice Challenge. We are Team Vel-Ice, and we are trying to resolve the Sea Ice Challenge and propose a new way of moving forward, which is moving forward sustainably. From research, we know that by 2050, shipping in the Arctic will double, and we need to improve disaster from happening, such as oil spills, which can amount almost to $2.8 billion per year, as well as heavy loss from biodiversity and many heartbreaks. In order to solve this problem, we need to take a systems approach, which includes all stakeholders of the Arctic, and these stakeholders are, first of all, nature, which is the closest to the Arctic. The nature and the ecosystem of the Arctic is very fragile and very unique, and therefore we need to preserve ice, biodiversity, water, soil, and air quality, as well as we need to collaborate with the people, indigenous groups, North America, China, Russia, and European countries that have access to this area, as well as the businesses that will actually thrive uh, during this increased traffic through the Arctic, which are the Arctic Bridge, Transpolar Sea Route, Northern Sea Route, and Northwestern Passage. Lastly, we need to include the government and specific councils, such as the Arctic Council, and areas, ministries of the natural resource and transportation. In order to provide a systems approach to our solution, to our problem, the best way is to use artificial intelligence in order to predict where the ice location will be with respect to wind movement. And the reason why we need to use artificial intelligence is because there is currently a gap in knowledge when it comes to all the data that is being recorded from the Arctic Circle. So currently we have information from buoyants, which are sensors in the Arctic that give us the location of sea, ice, and also information from the satellites. However, this information is not fully complete throughout the year because some data is missing. And so artificial intelligence will help us predict the missing data, and also will help us do that by using 40 years worth of data from recording drifting buoyants in the Arctic, as well as it will help us incorporate other environmental parameters such as ice concentration and ice thickness. So in order to conduct the AI model, we used Python Jupyter Notebook, Scikit, and also we ran our program on Amazon and SageMaker. The development process for the AI challenge was to first process the data, and in doing so, we eliminated a lot of the data that was not necessarily clean, and also that did not really make sense. And then this data, after we processed it, we analyzed it by doing box plots, histograms, and correlations maps, such as the one here, in order to understand what kind of further steps to conduct. Then we conducted a PCA analysis as part of the feature engineering, which helped us select the model. And in terms of model selection, we focused on regressions. Then we trained our model, and then we cross-validated, we optimized, and then we did this loop back and forth in order to optimize for the best machine learning model. And then we had our output. From our KNN performance, we can see that the plots reveal correlation between predicted values and actual values, and the closer to the diagonal line, the better. What we were able to observe is that the that sea ice tracking is important. I'm sorry, we have to edit this out. So our value proposition is that sea ice tracking is very important because we need to predict the location of the sea ice. Um, and here we are able to see that the location of the ice is moving in a circular manner throughout the years. And also you can see that the thickness of the ice is actually shrinking as it is moving towards away from the starting point. Also here in this chart, you can see that in 1980, when we first received the data, the ice thickness was pretty high, but then in the following 20 years, it decreased slightly. However, in the last 20 years, the ice thickness decreased significantly, much more, which is really telling us that there is more investigation to be done in with respect to the condition of ice in the Arctic. When we plotted the average ice thickness throughout the years, throughout the 40 years, we were actually able to observe that the average thickness is decreasing. And if we were to extend this line all the way to the zero line, we approximated that by 2060, there will not be any ice left in the Arctic. This is a very important problem to be part of, and we're really happy to be able to participate in bringing more clarity to Arctic ice movement. Thank you.